To truly appreciate the magic, we first have to strip away the fairy tale and understand the hard, brilliant science of light made by life. Bioluminescence isn't magic dust. It's biochemistry running on pure efficiency. At its core, it involves a molecule called luciferin and an enzyme called luciferase. When luciferin reacts with oxygen, catalyzed by luciferase, it releases energy not as heat. Like most chemical reactions in our bodies, but almost exclusively as light-cold light. This process is nearly 100% energy efficient. Compare that to the incandescent light bulb you might have in your home, which wastes about 90% of its energy as heat. Life cracked the code for perfect lighting millions of years before Edison even drew his first schematic. But why? For a forest organism, glowing in the dark is an expensive metabolic trick. It costs energy. In the ruthless economy of nature, such a trait only persists if it pays the bills, and in the pitch-black understories of dense forests, or in the dead of night, light becomes a powerful currency. For the famous ghost fungi of Australia, Omphallotus nidiformis, that eerie green glow is believed to be a sinister advertisement. It attracts insects that spread the fungus's spores, essentially using light as a lure for dispersal. For certain millipedes found in these luminous ecosystems, the glow is a warning. Label a clear, visual signal to predators that they taste terrible or are toxic. This is where the forest's conversation begins with simple statements. Stay away or come here. But this is just the monosyllables of the luminous language. The most profound glow, however, comes from a partnership so intimate it blurs the line between individual organisms. I'm talking about mycorrhizal networks, the so-called wood-wide, where fungi connect the roots of trees in a vast, symbiotic internet. Some of these fungal networks are bioluminescent. Imagine, then, not just a glowing mushroom, but a glowing cable, a living fiber optic thread connecting an oak to a pine to a fern. The light we see on the forest floor might just be the visible node of a network that is sharing not just nutrients and chemical warnings, but perhaps information encoded in pulses of light. Researchers are now investigating whether these faint glows could be a side effect of metabolic communication, a way for the network to manage its energy flow or signal stress. Every flicker we see in the dark could be a sentence in a conversation about water scarcity, insect attacks, or nutrient sharing happening in real time beneath our feet. This transforms the forest from a collection of silent individuals into a single, pulsating, communicative superorganism. Before you think this is just poetic speculation, consider this. Scientists have recorded electrical signals propagating through plants in patterns that resemble neural activity. When a leaf is eaten, an electrical impulse travels to other leaves, priming their defenses. Now, layer the potential of bioluminescence onto that. Could light be a more efficient, faster, or longer distance medium for such signals in specific conditions? The possibility is electrifying. It suggests that the forest is not just alive. It might be awake, aware in a way we are only beginning to perceive, using a medium of light we thought was our exclusive technological domain. This isn't just about pretty lights. It's about redefining the very fabric of biological intelligence. And if you think this is groundbreaking, wait until you hear about the specific forests where this is all playing out, places on Earth that feel more alien than any sci-fi movie set. But before we teleport to those locations, if your mind is already buzzing with the implications of a talking, glowing forest, then do this one thing for me. Hit that like button right now. Every like sends a signal to YouTube's algorithm that this kind of deep dive content is valuable, and it helps this video reach more curious minds like yours. Let's build a community that's fascinated by the real-world magic around us. So where on earth do we find these living light shows? The reality is both more widespread and more elusive than you might think. The most famous pilgrimage site for bioluminescence chasers is the Waitomo Caves in New Zealand, but that's a cave system, not a forest. For true terrestrial forests, we must journey to lesser-known corners of the globe. One of the most spectacular is the bamboo forest in Kyoto, Japan. Not at night. For glow, we go to the tiny island of Mesameyama in Japan's Wakayama Prefecture. Here, a species of moss known as Schistostega pinnata, or goblin gold, thrives in damp, dark caves and ravines. It doesn't create its own light through bioluminescence, but through a phenomenon called iridescence, or retroreflection. Its unique cell structure captures and reflects the faintest light, like moonlight, giving it an ethereal, self-generated glow. It's a different mechanism, but creates the same magical effect of forest floor that seems to emit a soft, greenish-golden light. For true bioluminescent forests, however, the holy grail lies in the tropics. The Atlantic forest remnants in Brazil, for instance, are home to Neonatha panis gardneri, affectionately called flor de coco by locals. This is one of the largest and brightest bioluminescent mushrooms known to science. Imagine a palm-sized fungal bloom that emits a persistent, greenish light strong enough to read by. A cluster of these can illuminate an entire section of the forest floor, turning tree roots and fallen leaves into a stage set. Then, travel to the subtropical rainforests of Taiwan and Japan, where the Mycena lux coeli, the heavenly light mushroom, fruits on the chinquapin trees. When it rains, the moisture activates its glow, making the tree trunks appear studded with tiny living LEDs, but the most profound experience might be in the temperate rainforests of the Pacific Northwest, USA. Here, the foxfire A dim glow from fungal-infested rotting wood has been documented for centuries. Early settlers used pieces of glowing wood to mark trails at night. This glow is faint, requiring your eyes to adjust to complete darkness for up to 30 minutes before the forest truly reveals its hidden luminosity. That's the key. These forests don't blast light like a neon sign. They whisper it. You have to become part of the darkness to see their language. This elusiveness is a protective mechanism. In a world of sharp-eyed predators, being a bright beacon is a liability. The glow is often tuned to specific wavelengths that are most visible to the intended audience, like certain insects, and less so to others. Furthermore, the glow is almost always tied to the organism's life cycle. A mushroom might only glow when it's ready to release spores. This temporality makes witnessing it a rare privilege. But what if I told you the ultimate bioluminescent forest might not even be on the surface? Recent discoveries in the subterranean world have revealed bioluminescent bays within flooded cave systems where glowing fungi and bacteria coat the walls and ceilings, creating starry skies underground. These hidden ecosystems suggest that the conditions for life to make its own light are far more common than we thought, waiting in the darkness of forests, caves, and even the deep ocean. The locations teach us a crucial lesson. Magic doesn't announce itself. It hides in the damp, the rotten, the unseen corners of the world. It requires patience, stillness, and a willingness to let your eyes adapt. And just as your eyes adapt to see the faint glow, your mind must adapt to a new reality. These aren't just pretty sights, they are ancient functional and intelligent systems. To truly understand their intelligence, we need to listen to the most silent conversation on Earth, the one happening not with sound, but with photons. And if the idea of standing in a Taiwanese rainforest or a Brazilian jungle, watching trees talk with light, gives you chills, then please take a second to subscribe. By subscribing, you're not just getting more videos, you're telling me you want to join these expeditions of the mind to explore the planet's deepest wonders from right where you are. Let's keep this journey going. Let's now listen in on that conversation. If the forest is communicating with light, what is it saying? The first layer of dialogue is pragmatic and personal. A bioluminescent fungus might be saying, My spores are ready, attracting beetles or flies that will carry its genetic material to new locations. A glowing millipede is screaming, "I'm poisoned, don't eat me." This is basic biological signage. But the second layer, facilitated by the interconnected mycorrhizal networks, is where it gets revolutionary. Plants and fungi in a forest are not solitary beings. They are nodes in a vast, collaborative network. Through the hyphae, the thread-like structures of fungi, they exchange carbon, nitrogen, phosphorus, and water. A mother tree can nourish a shaded seedling. A tree under attack by aphids can send chemical signals through the network to its neighbors, who then preemptively ramp up their own defensive chemicals. This is a verified chemical conversation. Now, introduce bioluminescence into this fungal network. The light could be a byproduct of intense metabolic activity. A surge of resource sharing, a distress signal from a wounded root, or even a seasonal change in the network's activity could manifest as a change in the glow's intensity, pattern, or color. Researchers like Dr. Karen Zimmerman have hypothesized that bioluminescence in fungi could be linked to lignin degradation, the process of breaking down wood. Since this is a primary role of many forest fungi, the glow could literally be a visible indicator of the forest recycling process in action. Think of it as a progress bar for decay, visible in real time. But could it be more direct? Could there be intentionality? While we must avoid anthropomorphizing, we can look at analogous systems. Deep in the ocean, creatures like the Hawaiian bobtail squid use bioluminescent bacteria to create counter-illumination, matching their underside glow to the moonlight above to hide from predators. It's a precise, controlled symbiosis. In a forest, what if a certain pattern of rhythmic pulsing from a fungal node signaled a specific type of nutrient availability? Or a fast, flickering glow from a tree's root zone indicated a bark beetle invasion? The network could use light as a faster, more targeted broadcast system than the slow diffusion of chemicals through soil. The evidence is circumstantial but compelling. Studies have shown that plants emit weak, ultra-weak photon emissions, a form of light far fainter than bioluminescence during stress responses. It's a stretch, but not an impossible one, to imagine that some organisms have evolved to amplify this into a visible signal. The forest light language is likely slow, patient, and utterly alien to our fast-paced auditory world. It is a language of gradients and pulses, not words. Deciphering it will require long-term monitoring, hypersensitive cameras, and AI pattern recognition to correlate specific glow signatures with environmental events. This isn't just botany, it's cryptography. We are trying to crack the code of the oldest internet on Earth, a network that has been transmitting data for over 400 million years. Every faint gleam in the dark is a packet of data in that ancient web. And if we can learn to read it, the applications are staggering. Which is the perfect segue to our next point: how this natural magic is already seeding the next technological revolution in our labs and cities. This isn't just about understanding nature. It's about partnering with it to build a brighter future, literally. And if you're fascinated by the idea of forests having their own silent internet, share this video with one person who needs to know this today. Sharing this knowledge is how we spread awe and inspire the next generation of scientists who might finally translate the forest's luminous whispers. The magic of the glowing forest is now leaping from the mossy floor into our petri dishes, our labs, and soon our cities. This field is called biomimicry or biophotonics, and it's where science fiction becomes science fact. The first and most direct application is in lighting. Imagine streets illuminated not by harsh LED streetlights, but by gentle, cool light emitted from trees or specially engineered plants. Scientists have already successfully spliced the genes for bioluminescence from bacteria and fireflies into plants, like tobacco and watercress, creating prototypes that glow. The startup Glowing Plants has been a pioneer in this space. The goal isn't to create novelties, but to develop sustainable, low-energy ambient lighting. A future city park could be lit by its own vegetation, powered entirely by the plant's metabolism. The second application is in sensing and reporting. Remember the idea that a forest's glow changes with its health. We can engineer that. Researchers are working on creating smart plants that use bioluminescence as a biosensor. A plant could glow a specific color if it detects a pathogen in the soil, a toxin in the air, or a shortage of a specific nutrient. Farmers could walk their fields at night and immediately see from a distance which crops are under stress, allowing for hyper-precise intervention. This is real-time, living diagnostics. The third and most profound impact is in medicine. The luciferase enzyme, the key to bioluminescence, is a revolutionary tool in medical imaging. By attaching luciferase genes to specific cells like cancer cells, scientists can make them glow inside a living organism. This allows them to track the spread of cancer, the effectiveness of drugs, and the behavior of stem cells in real time, non-invasively. The firefly's glow is literally helping us fight our deadliest diseases. Beyond these, the principles of cold light are inspiring new types of screen displays and low-energy lasers. But the most futuristic application lies in the concept of the network itself. The Wood Wide Web, with its seamless, decentralized, and resilient communication, is a model for designing better human networks. Our current internet is energy-hungry and vulnerable. Could we design a distributed sensor network for forests or farms that mimics the fungal network, using low-energy, self-sustaining nodes that communicate through light? The glowing forest is more than an inspiration, it's a blueprint. It shows us how to communicate without wires, create light without heat, and build resilient, interconnected systems. This is the ultimate takeaway. Protecting these magical forests isn't just about preserving beauty. It's about preserving the world's most advanced R&D labs. Every time a bioluminescent forest is cleared for agriculture or development, we might be burning the library that contains the secret to clean energy, advanced medicine, and sustainable computing. These organisms have had hundreds of millions of years to solve problems of efficiency, communication, and sustainability. We are just beginning to read their patents. The value locked in that soft, green glow is incalculable. It represents a future where technology is not separate from nature, but a collaboration with it. And to ensure we get to that future, we need to not only study these forests, but fiercely protect them, which leads us to the most urgent and sobering part of our journey, the fragile reality and the fight to keep these lights from going out forever. This is a call to action that goes beyond the digital realm, and I need you to hear it. Here's the painful, urgent truth. The very conditions that create these magical forests are under siege globally. Bioluminescent organisms are often canaries in the coal mine for ecosystem health. Require specific, stable conditions, pristine darkness, clean air and water, undisturbed soil and complex, old-growth relationships. Light pollution from nearby towns and cities can literally drown out their subtle glow, disrupting the reproductive cycles of fungi and the behavior of insects they depend on. A street lamp can silence a conversation that's been happening for millennia. Chemical pollution from agriculture, pesticides, and fertilizers seeps into the soil, disrupting the delicate balance of the mycorrhizal networks. These fungi are incredibly sensitive to toxins. Without the fungal internet, the forest's immune system and communication grid collapse. Deforestation is the most direct threat. The Neonothepanus gardneri mushroom in Brazil exists only in specific pockets of the endangered Atlantic forest, over 90% of which has already been cleared. Climate change brings altered rainfall patterns, droughts, and warmer temperatures, pushing these sensitive ecosystems past their breaking points. A warmer, drier forest is a darker forest. In the bioluminescent sense, the magic fades. But here's where you come in. This isn't a hopeless conclusion, it's a mobilization order. First, you can become an advocate for dark sky preserves and responsible lighting. Support initiatives in your community to use shielded, downward-facing lights that reduce sky glow. When you visit natural areas, use red light headlamps and minimize artificial light. Second, Support organizations dedicated to preserving old-growth forests and biodiversity hotspots globally, like the World Wildlife Fund, the Nature Conservancy, or local groups in bioluminescent regions like Brazil's SOS Mata Atlântica. Third, be a conscious consumer. The choices you make, from the food you buy to the products you use, impact global supply chains that drive deforestation. Choose sustainable, certified products whenever possible. Finally, and most simply, share the wonder. Videos like this one create emotional connection. When people feel awe, they are motivated to protect. Share this knowledge. Talk about these forests not as mere curiosities, but as vital, intelligent, and invaluable libraries of life solutions. We started this journey with a shocking hook: forests that talk with light. We've traveled through the science, the locations, the language, and the technology. Now we end with a responsibility. These glowing forests are a testament to life's creativity, a beacon of natural intelligence in the darkness. They hold keys to our future, but they are fragile. Their light is a whisper in a world that is getting noisier and brighter every day. It's on us to lean in, to listen, to protect that whisper, to ensure that centuries from now, humans can still walk into a forest on a moonless night, let their eyes adjust to the profound darkness, and witness the earth itself breathing light, telling its ancient, silent stories. Don't let that story end. If this journey through the world's glowing forests moved you, shocked you, or filled you with wonder, I need you to do 3 things right now. First, hit that like button. It truly helps this channel grow. Second, subscribe and ring the notification bell so you don't miss our next deep dive into Earth's mysteries. But third, and most importantly, be a voice for the magic. Share this video on all your social platforms. Tag a friend who loves nature or science. Start a conversation. Let's turn the awe from this video into a wave of awareness. Because understanding is the first step, but sharing that understanding is what leads to real protection. Thank you for watching, for listening, and for caring. Stay curious.